Now it is possible to make patterns with points, and an obvious pattern is a line. And in fact what you have to be able to do in this subject is to draw lines on these Cartesian coordinates. And here we go, let's have a look at an example. In this problem we are asked to graph the line y equals x plus 1. What we really want is a set of ordered pairs that follow that particular rule or this equation. And you can take any values of x, but generally you would like to take values that are easily calculated. I've taken an x equals minus 1. That gives me minus 1 plus 1. It gives me a y of 0. Then you can take another point for x, 0 for instance. If you substitute that in, you get a y equals 1. And a third one, x equals 1, gives me a y equals 2. It's normally written up in what is called a table like this, an ordered pairs table. X there, y there, and there you've got the values you just found. That will appear on the next screen. And now we are ready to actually graph the line. Here we've got the axes. You put the first point down, that's the negative 1, 0. The next point is the 0, 1. And the third one is 1, 2. And you draw your line through it. And that's how that first line is drawn. You actually only need 2 points, but it's always good to have a third one as a check. Now this was quite a simple example. You understand, of course, that it can become a little bit more difficult. Let's get a bit more practice in, though, of this type of equation. So problem 2 coming up now. Here we have to graph y equals 2x minus 1. Same idea, I just select any x value and I take easy values for x, like 0 for instance. I substitute a 0 in and I get a y equals negative 1. I substitute an x equals 1 in, I get a y equals 1. And then a 2 gives me a y equals 3. Table coming up like this. Here we've got the axes, the x and the y axis. Let's put the points in. 0, negative 1 is over there. The next point is 1 with 1, and the last point is 2 with 3. That last point is really a check. Here goes the line, and you've drawn your graph. You've drawn the graph of the line. Now there are 2 special lines I just want to draw your attention to. They don't look like lines, or they don't look like equations of lines, but they really are. Got an example here. Graph the lines x equals 3 and y equals negative 2. Here we've got the axes. Now, how do we graph x equals 3? Well, basically what you get is the line that has all values of x equals 3. It doesn't matter what y is. So that's this particular line over there. Because on this line, all the x values are 3. It doesn't say anything about y, as I've said before. So this is it. There we've got the y-axis, by the way, and that would have equation x equals 0. Now what about y equals negative 2? We're looking for a line where the y values are always negative 2. That is this line over there. Similarly, the x-axis would actually have equation y equals 0. So there are some unusual lines there, but we come across those quite a lot. Well, we're going to have a look at the equation of a line in more detail after a break. Let's take a short break now. We are now going to have a look at the general equation of a line. There are in fact 2 things that determine a line. The first thing is what's called the gradient, the slope of a line, and the other one is where it cuts the y-axis, and that's called the y-intercept. Let's look at the graphic here. Here we've got lines that all have the same gradient, they've got the same slope. On the other hand, in this particular diagram, we've got all lines passing through the same point. Now once you know the point and you know the slope of the line, then the line is completely determined. This leads to the definition of a slope. In fact, if you look at what a slope is, then it is how high you go up when you go in a horizontal direction. And what we normally do is we take the horizontal direction to go in this positive direction, and then the ratio of the rise over this so-called run, that is then defined as the gradient. Here's the definition: gradient equals rise over run. Let me give you some examples of different gradients. In the first example, we've got a horizontal line. Well, there is no slope at all, and so therefore the gradient is 0. In the second example, the line makes an angle of 45 degrees. That means that for every unit across horizontally, you go 1 unit up. The gradient would be 1. Now, this particular line hasn't got a gradient at all. In fact, we say it's undefined. We'll come back to that example a little bit later on. Then we come to the fourth example, and there we've got a very narrow negative slope, as it is called. I've approximated as 0 point or negative 0.3. It is negative because for every unit across, I'm going about 1/3 of a unit down. It's a negative slope. It's a fall, in other words.